Good. All right. Great. All right. Hi, Martin. Hi, everybody. Thank you for having me here. As Martin said, I'm a physicist, and actually, I need your help because in the beginning, I would like to show you, what is the hard problem of consciousness, what is the big mystery there, and then to show you how I think we can actually solve it with physics. And in the end, I need to ask you, I have a couple of ideas how to test it empirically, but because I'm not from neuroscience, I need your help. So let's see, in the end, I would like it to become like, brainstorming. And a couple of months ago, I met Sarah from your lab in the Donders Sleep Conference. Thanks to my wife, I'm going to all the sleep conferences, not only to consciousness conferences. And then I submitted a poster, it was accepted, although it's about consciousness and dreams. So yeah, I guess it was good enough, And Sarah approached me after and suggested that we can collaborate because she has a great data set of people from different stages of the sleep cycle and dreams. And it sounds great. So I'll show you. And Sarah, I think she's somewhere in the Zoom, right? And and yeah, hey Sarah. So yeah, again, in the end, I will show you a couple of ideas what I thought to do, which analysis we can create, and let's talk about it. But first of all, let's start from why I'm engaged with consciousness. And let's start from my hero, I don't know, but Albert Einstein. I love to start with Einstein always. I don't know why you don't see. Yeah, maybe if you can, I don't know if you can do something with that, but if not, never mind. So Einstein said, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. He to whom the emotion is a stranger, who can no longer pause to wonder and stand wrapped in awe, is as good as dead. His eyes are closed. Shouting. Okay. And I think he's right. I mean, for me, I went to physics in order to understand all the big mysteries that we have in nature, like what is going on inside the black hole, how come we have the Big Bang to start with, and also consciousness. Consciousness is one of the biggest mysteries in the universe. For some, okay, take some time, but you can see. Okay, and I think if we solve each of those mysteries, it's like a door that we open to unveil more of reality. So that's why this is what I'm trying to do. So today it will be a bit different. It's, first of all, we will speak about this mystery and how can we solve it. Because looking at this, 1.5 kilos of gooey, bloody flesh, isn't it amazing that it should create our mind, our thoughts, our feelings, our consciousness, dreams, everything, right? How can it be? And so before we dive in, actually, Pixar has an answer for us. So I want to show you something. I want to show you part from Toy Story 4. And let's see if the volume will be on or off. I wonder if I need to do something there. Yeah, it's off. So, so now, what are we going to do with that? I don't know.
Not completely on the laptop. It only has to go via Zoom.
So
Laptop is not allowed to play any audio. It's just about sharing.
So in my laptop, it's off. So I guess it's because of Zoom.
Your laptop sound still on, right?
No, in my laptop here, it's off.
Here, for some reason, it's on. So I guess
Because of Zoom, I'm not sure. Let's see.
Still. Oh, I muted you again. You have to stay muted. You just have to share the sound via Zoom. But not unmute.
Here's the other settings of Zoom, right?
Yeah.
You can share only the video, not the, it's a video on your folder.
It's a video on my phone.
You go via Zoom, they say share, but not a or again, yes, say share. Share, but choose not the presentation, but your video.
Okay.
But you should open your video first on your folder.
Ah,
Open it on your computer.
so not through the
Yeah, and then
through the presentation. Oh, you know, Zoom will create so many problems with the.
maybe you can skip it then.
Skip it, I'll just
Skip
skip
it.
it.
Skip it.
All right, let's skip it. It's not that important. Okay. So just skip it. Maybe later on.
What would have the video shown?
So the video showed two like a fork and like a plastic fork and a plastic knife or spoon or something like that. And the spoon asked the fork, "How am I alive?" And he's saying like, "I don't know." So, and this is the question, huh? How can a matter like the brain or the plastic fork can create consciousness, right? So let's see. You think you have some kind of solution now? Okay. But first of all, we need to clarify, to define what consciousness is, because for many people it's completely other things. So I'm following Nagel from the 70s. This is like the canonical definition of consciousness. If there is something that is like for the creature, then the creature has consciousness. For example, the cupboard here, most likely there is nothing that is like to be discovered, right? It's like there's no one there. It's all dark, if you like. So there's no consciousness for the cupboard, like when we will be under anesthesia, or maybe in deep sleep without dreams. But then when we are dreaming or awake, there is something that is like for us, so that's why we have consciousness, right? So this is the definition. And in other words, it's just to say that when we experience ourselves and the sensory information, then we have consciousness. But just in cleaner words. Now, there are lots of different theories for consciousness, but most of them just neglect the most important part, the phenomenal part of consciousness. And if they don't neglect, I think that they just don't do a good job with giving an answer for the mystery, for the hard problem, for the explanatory gap that soon I'll show you. So the mystery is that when we see an apple, when I see an apple, I will just see the apple, this three-dimensional round red shape. So this is my first person point of view. But then when someone else will look at my brain and check for the neural patterns, we can find those neural correlations of the apple. And we can even maybe, if we will somehow can create a stimulus in my brain that will create the same neural pattern. Most likely, I will see in my mind's eye the apple. but still, they are different. This is from a third-person point of view, and this is just a neural representation, not what I actually see. So there should be some kind of mechanism of a function that takes us from the third-person point of view to the first-person point of view. Now, you might ask, so the question is, what is this mechanism? And this is where the problem starts. Now you might ask, well, maybe this is just the apple or something like that. Sorry, the experience of the apple. But it's not the case because actually we still don't know even, how to describe exactly the neural representations that we have in the brain. But we know that it's, some kind of a multidimensional state space and a very complex representation there. But in the end, what I experience is something completely different. It's a 3D round and red shape. So it's just cannot be the same thing because they don't have the same properties. So there should be some kind of a function or something in order to get from the properties of the neural pattern into the actual properties that I experience. And also, what I experience is private. You cannot really see my experience, like that's why we need to ask, of course, for reports from the subjects. But from the third-person point of view, if we have a good machinery, it's public. We can all measure the same neural pattern. So again, we see that they are not the same, they are not identical, and then we need to find how we can go from third-person to first-person point of view. The problem is that there is no such mechanism, it seems. It seems that we cannot do a reduction here from the experience to the actual neural mechanisms. Because in every area of the brain that I will look, I will see just more and more neural patterns. Even if I see emergence of all the neural patterns in my brain to one giant neural pattern, it's still a neural pattern. It's still not the same, and still it's public and not private. So it seems that this mechanism is outside of neuroscience. It's something that is more than just calculations and information processing. It's something more, and we have no idea what it is. And this is the explanatory gap. There is a gap between the third person and the first person point of view, and it seems that we cannot do this reduction like we did for temperature. We did a reduction to the movement of molecules, right? Here we would like to do reduction from the experience to the neural patterns, but it seems impossible. Even more than that, Chalmers, David Chalmers, the philosopher, in 1996, described it as the hard problem of consciousness. And he said, well, this phenomenal consciousness, it seems like it's independent for any physical dynamics even, not even neural patterns, because every dynamics, it's something public that we can measure from the outside, and it will have all those properties of of maybe like all the neural dynamics, but still it's different than what I experienced. So what is going on here? How can the brain create consciousness? This is a very big mystery, and this is the hard problem of consciousness, and this is what I would like to solve. Something small, So what we need to understand here are like 4 peculiar properties of phenomenal consciousness. It's private, as we said. It has something that is like. It's immediate. Immediate means exactly that I experience immediately the apple itself and not the neural presentations, right? It's not that I say, oh yeah, I feel now neuron A fires to neuron B to neuron C. I just have immediate experience of the apple, right? And it has subjective point of view. So those are the four properties that we need to explain what is the mechanism, how can we get to those properties. Now, because it's such a hard problem, we have lots of different theories and philosophical ideas. No one can really do it. In one hand of the spectrum, we have even illusionism that will say, oh, maybe it's all just an illusion. So maybe it's just an illusion that I see you right now and I have your experience. I have to say this is very weird, from Descartes times that, the thing that I really can be sure about is my experience. But then on the other hand, we have another extreme that says maybe we need somehow to add to physics phenomenal properties alongside the regular properties. But then this is very weird as well, and we see in physics that there is no room for like those kind of properties. So we are just stuck. And you can think about panpsychism. Maybe everything has some kind of phenomenal property. Also, I don't know, rocks and electrons. But nothing really can solve this problem. And that's why I thought that actually we can do here something. Maybe it's a bit like in the days before Copernicus, where the astronomers thought that Earth is in the middle, and then all the sun and the stars surrounding around the Earth, and then all of their paths are very difficult and very complex, and there were lots of open questions that I didn't know how to solve. And then came Copernicus, changed only one assumption, that the sun is in the middle. All of a sudden, all of the path of the stars are very simple. All the questions just dissolved naturally, and science could bloom. So what if this is the situation now with consciousness, and the hard problem is just because we have an assumption that is wrong. And this assumption, I suggest, is that consciousness is absolute. It means that if I ask, does Martin have consciousness? Well, it's a good question. And there should be one answer, absolute answer that everybody needs to agree on, if it's absolute. But maybe this is the problem. Maybe we need to think of consciousness as a relativistic property, something that is dependent on the observer, or the frame of reference that we are here. Because in physics, we know that there are phenomena that are like this, like relativistic. So now I want to show you, first of all, what does it mean to be a relativistic phenomena? And then later on, I can show you then how can it help us to solve the hard problem. So my first example is about velocity. We know that velocity is a relativistic phenomenon. Each of us, if you think, if you remember, all of us had this experience like what you will see now in this video, that we are not sure who is the one that's moving and who is the one that are stationary. For example, here, is the woman in the train moving, or maybe the other train outside is moving? Only in the end we can say, but for now it seems plausible that the two are moving. Only in the end we see, oh, it's okay, it's actually the other train that was moving. Now, even Galileo already saw this phenomenon and understand that velocity is relative. There is no one answer for who is moving and who is stationary, because if we do every experiment that we can do, will show us that actually we are stationary. Like we can throw a ball to the air, it will come back to our hand, even though we are in constant velocity. So we cannot distinguish between the two. And that's why there is a relativity here. So this is called the principle of relativity. It's the basic principle of Galileo relativity and Einstein relativity. And I will use it over and over again, this principle, as you will see soon. So according to this principle, there is no one absolute frame of reference. Instead, there's nothing above and beyond frames, the other different frames of reference, which means that there is no like God eyes view that can tell us, oh, this is correct, this is not correct. It's all about the measurements that the different frames can do. So if we have two frames, for example, Alice and Bob is moving in constant velocity, both of them will create experiments for themselves, and they will conclude that they are stationary. Who is right? Both of them are right. Now, because we have observers from different systems that measure the same results, it means that they are equivalent. We cannot distinguish. There is no absolute frame that will say who is really moving. And they have the same laws of nature in both of their systems. Okay, so this is, in a nutshell, the principle of relativity. Now, my claim is that we can use that. It can help us, for example, understand why we have this third person and first person point of views. It's actually two different frames of reference. But first of all, couple of important remarks here. First of all, I mean, this is part of physics. So it's not about perception. It's not about logic. It's about the laws of nature. The relativity here is because all the laws of nature are the same, because all experiments will show you the same results and we cannot distinguish, okay? So measurement and observer here, it's a bit different than what we think, in our day-to-day life. Like observer is not about consciousness at all. Everything can be an observer, even an electron. And then like measurement here, it's not like I'm going to the lab and using a meter or something. Measurement here is any interaction at all. So here the two electrons have interaction because of electromagnetic force. This is a measurement, okay? So it's not about humans, not about consciousness, and not about labs, just about interactions, and anything can be a frame of reference and an observer. Remember that, it will be important later on. Now, people ask me often, in the principle of relativity, it's true that there is no one answer, but it's all about the same, the same measurement or the same property, like about velocity, for example. Is it zero or is it different than zero? But both of them are just different point of views about the same property. How can it help us with consciousness? In consciousness, we have different properties. We have like neurons and consciousness, right? Seems very different. So how can it help us? And the answer is that part of the principle of relativity is relationalism. It's another aspect, let's say, of relativity that I have to say until today, physicists didn't notice it too much. And now in my new paper, I'm starting by showing that principle of relativity and relationalism are actually equivalent. And this can help us very much. What is relationalism? Now, the existence of properties is not absolute as well. So in order for a natural property to exist, we need relations, like the relations that were in the system. Because of them, now we have some property in our frame of reference. So let me give you an example of what I mean by that. And the example is the equivalence principle of Einstein. So Einstein, while he's trying to understand what to do with gravity, he thought of this equivalence principle. He understood that we can extend relativity also to gravity and acceleration. And actually, we cannot distinguish between system under gravity and system under acceleration. Think, for example, of this astronaut. Now she is here on Earth, inside the spaceship. when she will release the ball from her hand, the ball will fall because of gravity. This is fine. Now think of another astronaut, Bob, for example. He is in out of space, far from any star, has no gravity at all. But his spaceship accelerates upwards. Now, when he will release the ball, what will happen? Because now the ball is detached from him and the acceleration, he will see the ball actually goes down to the floor. Exactly what we would see if we will be under gravitational force. And that's why Einstein realized that this will be the case for any experiment that Bob can do under acceleration. And that's why, because of relativity, again, we cannot distinguish between if we are under gravity or under acceleration. They are equivalent. So again, there is a relativity here, like we saw before. For example, let's say that we have outside, this is Bob outside. He's looking at Alice inside our spaceship, accelerating spaceship. Alice will say, I have gravity. I'm stationary, I'm not moving, and I see that I have gravity, everything falls. But Bob will say something different, right? He will say, no, you are accelerating, there's no gravity at all. Now, and she will say, yeah, I have gravity. Now again, who is right here? Both of them are right. There's no absolute answer here, it depends on the frame of reference. But now notice that it's not about the same property anymore. We have here two different properties. From the external, we have acceleration, but internally, we have gravitational force. So it's not the same thing. Still, like how can I say gravity manifested according to the relations that Alice measured. Okay, so this is relationalism. How different properties can be manifested just because of different relations that we are measuring. It's a bit like a coin. When you see head or tail, both of them are real, just from different points of view, right? So this is what is going on here. So now think what will happen if Alice and Bob, if they don't know that this is the situation, that it's all relative. Then they will continue to argue who is right, what is the absolute answer here. So she will say, I'm under gravity, and I'm stationary. And he will say from the outside, no, I'm stationary. You are under, acceleration. And she will continue to say, no, I do all the measurements, I have gravity. So he will just say, oh, you're delusional, come on. And then, as a counter argument, she will say, oh, well, I know what I measure, so maybe I have like a private property that you cannot measure from the outside. Now, this sounds awfully like consciousness, like what we have nowadays in consciousness, right? Like, she will say, I have phenomenal consciousness. I don't know, you have only neural patterns. And he will say, no, I have consciousness. You only have phenomenal consciousness. And they argue who is correct here. And he will say, it's just a delusion. You don't have it. And she will say, oh, it's private property. But both of them are wrong. It's not that that it's a delusion. It's not that it's private. It's just that phenomenal consciousness is relativistic, and both of them are in different cognitive frames of reference. So this is the basic idea. So what I suggest is that from the third person frame of reference, actually, we can measure only neural patterns, right? But no consciousness. And from the first person frame of reference, we are not measuring that we have neural patterns because of directness, right? We measure only that we have consciousness. And when we asked, how can we do a reduction here? What is this mechanism? we didn't take into account relativity. We didn't take into account that while Bob is measuring that he sees an apple, Alice is measuring that he has only neural patterns, and both of them are right. It's again just to see a coin from different sides. And just like that we cannot reduct head into tail, we cannot do a reduction from phenomenal consciousness into neurons. Although both of them are really there, right? Are an actual physical property. So consciousness is an actual physical property, if I'm right. Another thing that it means that actually consciousness is not really private anymore. Because according to the principle of relativity, we cannot privilege any frame. So we must have a transformation, how we move from one cognitive frame to the other, from third-person frame to the first-person frame. And actually, in my first paper from 2022, I developed the mathematical transformation between one cognitive frame of reference to the other, and third person to first person. Now, it might, in order to do this transformation, we need to change the dynamics of our brain to be like the dynamics of the other brain, because when we change the dynamics of our cognitive system, we actually change the cognitive frame of reference that we are in. It's like here, if Alice from the outside would like to be in the frame of reference of Bob, she needs to step up and to go inside the train, and then they are in the same frame of reference. So also here we need, if we can take Alice and Bob and somehow change the dynamics of the cognitive frame of Alice to be like Bob's, then both of them will be in the same frame, and they observe the phenomenal consciousness of the other. So no privacy anymore. It's just very, very hard. We have no idea how to do it. Now it might sound like science fiction. Actually, there is something here that we already now can see. And this is a very interesting case of Krista and Tatiana Hoggins. They are conjoined twins. They share the thalamus, actually. And they are sharing a bit of their cognitive frame of reference. Let me show you. So again, I'm not exactly sure what to do with this cell. I don't know how we can do it. But there is here a very interesting demonstration of that, of how they actually can share some of the cognitive frame. Do we have time for that? I don't know. Well, maybe in the end I will show you. Maybe in the end. But the idea here is that one of them sees, let's say, a teddy bear. The other, the mother puts like her hand to cover her eyes, and still she will say, yeah, this is a teddy bear, right? Because they actually share some of their cognitive frame of reference. Okay, so until now, this was my first paper, where I just suggested a plausible way how to solve the hard problem. Now it's like, okay, maybe it's not that hard if we take consciousness to be relativistic. But something is still missing. What is missing is that what is going on exactly in the internal frame of reference? Like here, we can understand what is going on. What are the relations that Alice measures and why she will measure that she's stationary and has gravity. But I didn't tell you what is going on inside of Bob's head. What are the relations that manifest phenomenal consciousness? And this is what we need to do next. I need to show you what exactly is going on inside. First question, do they have different measurements to manifest different properties? The answer is yes, because when we are in a third-person point of view, it's true that we need to use our sensory devices like the eye, and our eyes capture the substrate of neurons. So that's why this is what we measure. Those are the relations that we measure from a third-person point of view. From a first-person point of view, inside we don't have any sensory devices at all, right? That's why we cannot measure our own neurons. So the measurements there seems like the interactions, remember measurements is an interaction, the interactions between different areas that are active in the brain. And so it's a completely different measurement than what we can do from the third person point of view. So in that sense, it makes sense actually that we will measure different relations and different physical entities because of that. But what are those entities? Okay, I mean, why it's how can we get to those four peculiar properties that we spoke before, have something that is like immediately in all those? Let me show you. In order to show you, I'll take you now to three scenarios. Each scenario will extend the principle of relativity a bit more until in the end, I will show you this is, that, oh, we got to the four properties that we wanted. So first scenario, think about water, for example. So water, we know that they are composed of H2Os, but then there is some kind of emergence here for wetness, for example. But now think about it. It's also relative phenomenon as well, because if we were in a micro scale, we would only measure the molecules, a very complex behavior of molecules, but not the water themselves. Only when we are in the macro frame of reference, actually in the macro scale, if we are big enough, then we will only measure water and temperature and all the macro properties, but not the molecules, not the micro properties. So even here, we can see that it's actually a relativistic phenomenon. And think even that maybe in the future, we can create different molecules, different than hydrogen and oxygen, but create them that all of their interactions in the macro scale will create the same macro properties like water, wetness, and everything that we can measure about water, we can measure here, although the molecules are different. Let's say that we can do it. Now, there is a very famous question in philosophy, is it water or not? But again, this is from an absolute way of thinking. What I suggest that if we take the principle of relativity, there is no one absolute answer here. We can choose a frame of reference where they will be indistinguishable. And this is the macro frame of reference. Like if we measure only all the causal relations in the macro scale. And then we cannot measure the molecules themselves, so here they are equivalent. It is water, right? But if we measure it from the macro, in the macro frame of reference, of course they are not equivalent, it's not the same, right? So now it depends on the frame of reference. And we have actually different elements here because of relationalism. So when we measure all the micro relations, we have elements, the elements of molecules. But then in the macro frame of reference, we measure different causal structure, different causal relations, and that's why all of a sudden we manifest different elements, not molecules. Now the elements will be water droplets, right? So we have different elements now. So this is due to the causal closure. We have a closure now, a causality closure of only the macro causal structure, for example. So this is what we need to remember from this scenario, that if we have a causal closure, we can actually manifest different elements. Now we can move on to the weirder situation in scenario 2. Here, let's say that we try to simulate all the universe. And maybe it's in the future, and we know already all the rules. We know all the particles, all the forces in the universe. We have the complete theory of everything, and physicists like myself are out of work. And we write all those equations and run the simulation. Also here, let's apply the principle of relativity. We can see here two different frames. The first frame is the external frame, which is the usual frame that we are used to. A frame where we measure that there is a computer with the substrate of the computer, electricity, logic gates, and everything are just like zeros and ones. That's it. This is what we have. It's just a simulation. But then we can choose another kind of frame, internal frame. In the internal frame, we take the variables of the equations, and now those variables, they interact with each other. So they have some causal structure, some causal relations between them. Now, all those are different variables and how they influence each other. So let's say that we choose a frame where we take into account only those causal relations between the variables, not the substrate of the computer, electricity, and so on. So then we have a new causal closure here, because we are now only measuring the relations between the variables themselves. What will happen in this internal frame of reference? And we know that those causal structures and chains and all those relations manifest elements, right? But which elements will they be? Well, because it is according to the variables of the simulation. The variables are according to the real world elements. What will happen is that in this frame, the elements that will manifest will be the real world elements over, like again, but this time inside this internal frames. So we will have there like space, gravity, stars. Let's say that we stop after stars. Okay, no consciousness here still. So now we actually manifest all those elements again, but in order to see that, if you like, we need to be, of course, in the internal frame of reference. For example, let's say that we have matrices of position of all the particles in our simulation, and we have all the matrices, how to translate them, how to rotate and everything. In the internal frame of reference, all those relations between them will manifest the actual 3D space. So for them, we have the 3D space there and gravity and everything. This is very weird, right? It's a very weird result that like all these properties and entities are real in the internal frame of reference. Now, it seems a bit like we have here like some kind of a gap, because from the outside, what we have are just numbers or just like zeros and ones, just a simulation. There's no gravity there, of course. But from the internal frames of reference, there is gravity, actually. So from the inside, you can say it looks like it's private, because only when you're inside, you can measure gravity, not from the external frames. And it's immediate, right? From the inside, you just measure gravity, stars, particles. From the outside, you are not measuring all those, I don't know, zeros and ones and electricity, although all those states mediate what you measure from the inside. But you don't measure it, right? You measure the manifestations. So it seems immediate. So it seems that we have created here an explanatory gap, like what we have with consciousness. But now we know, of course, that there is no gap, right? It's just relativity. It's just two different frames, external and internal, and that's why it seems that, of course, we cannot do a reduction from the gravity of stars that we have in the internal frames to, just those zeros and ones that we have in the external frame. So we made some progress here, because if you remember, we wanted to know what are the relations that will manifest those four properties that we have in phenomenal consciousness. And now we know how to manifest privacy and immediacy. We just need to create such a causal closure like we saw here in the simulation, and we will have immediately those two properties. Okay, so we are in a right path in order maybe to solve what is going on here, what is phenomenal consciousness. So we can continue on. Even more than that, now we have a very important property that we have in functionalism, for example, the multiple realizability, which means that in order to have, in order to have consciousness, for example, or in order to have the simulation, the substrate itself is not important. We can realize the same function in different materials. So we have the same thing here, because according to the principle of relativity, what matters are the relations, are the causal relations. This is what matters to manifestation, not the substrate. So if we preserve the same causal relations, and we are in some causal closure, like in the internal frames, then the substrate is not important, and we can have the same manifestation. Okay? So we reach that from physics, from relativity. It's not an assumption. Okay, so now we can continue to consciousness itself. This is scenario 3, the first person frame of reference. So we start from a cognitive frame of reference, our brain. We don't have all the equations for the simulations. Instead, our brain learn those rules, let's say. So our brain sees inputs, learns the causal relations between inputs. First of all, it represents them in some gist. That's why you see those weird balls. It's just a representation. It's the gist, like essential part of the input. It's not the whole thing, right? Just a representation of it. But after we learn enough causal relations, now the brain can create a simulation in order to predict what will happen next and what is going on now. So it creates a simulation. So now all those variables, all those representations will be the variables of the simulation. And as we saw before, in those internal frames, the inputs will be manifest again, right? But now just inside the simulation. We have this causal closure. But now we need to add another thing, because if the cognitive system really wants to predict what will happen and to survive, it needs to simulate itself as well. So now, let's say that we see an apple. So we have the representation of the apple. Now we have also a representation of the cognitive system itself. Again, some gist of it, of course, not the whole thing. And of course, all the relations, the causal relations between the apple and the system, the cognitive system. And then this is how the cognitive system can choose the appropriate output. Okay, now we know that it will be, now in order to do that, actually, we need also a different kind of representations, those latent representations that can change the cognitive system itself, right? So it's like I call it like a self-representation. One example for that can be valence, like to approach or to avoid something. Is like good or bad for me. So for example, the apple is good for me, I learned, and that's why I approach it and eat it, right? But now think about the simulation. All of those representations needs to be the variables of the simulation now. So inside the simulation, all those elements will be real, right? In the internal frames. So the apple, of course, will be real, like the apple from the outside. But what will happen with those latent representations, those latent variables, self-variables now? What will happen with them? Which kind of physical manifestation will happen here? Right? We know that those self-variables need to be manifest into elements. It's like a physical element. What are the properties of those physical elements? We know, for example, that they have causal relations only between them and the internal cognitive frame of reference. No other relations. So it doesn't have the causal relations to manifest like our regular elements from the environment. They cannot be manifested as molecules, I don't know, chemical elements or stuff like that, because they don't have those relations, like the apple has, for example. But still, they are physical because they have causal power here. They influence our internal cognitive system. So they need to manifest to be real elements somehow, but completely different from anything physical that we know from the outside. Now look, they are even more private than before. Not only they private because they are in the internal frame, they are private because they only have causal relations with only one internal frame, the cognitive internal frame, right? So they are like very private. And they are about subjectivity because they influence the internal cognitive system itself, right? So my claim is that the only possible way for them to manifest as physical elements are with phenomenal properties that have something that is like, just because they are so different than anything else from the outside, but still they have causal power. And then the only system, the only frame that can measure them, the internal cognitive system, let's call it the first person frame of reference, right? Because this is the only first person frame that can measure those phenomenal properties. So now we reach also that how we can get to subjective point of view and to have something that is like. Now you can ask, is it a good proof? Is it, like a complete proof? Actually, there is a bit more, but in sake of time, I think I will skip it for now. If you want, you can ask me in the end in the questions. And there is a bit of more how to prove, how to do it like a complete proof. But again, for now, let's skip it for now, okay? One second. Right. But this is the idea of my new paper. So let's sum it, and then we can, discuss how I can prove it, right? So to sum, we asked what are the relations that should be internally in order to have phenomenal consciousness. And we saw that we need this causal closure of the simulation to be private, and that those self elements only have causal relations with only one frame, this internal cognitive frame of reference, right? And immediate, it's because of the causal closure. So they immediately manifest as phenomenal properties. They have subjective point of view, as we said, because they influence the internal frame of reference, and they have something that is like, because it's phenomenal. This is the only way that they can be manifested. So if Bob Dylan will come to you and ask you, wait, but what is phenomenal consciousness? Now you know what to tell him. Well, it's a physical property, of course. It is manifested in a simulation according to the self variables of the internal cognitive system. Right now, I hope this complex sentence makes sense. This internal cognitive system, this is our first person frame of reference. It means that we live in a simulation, right? I mean, in our day-to-day life and in dreams, we are in the simulation. We have this internal cognitive system. This is where we manifest consciousness. This is very interesting to think about it like that. So yeah, so what is the reduction here? There is no reduction. Instead, we have phenomenal consciousness, you know, as this manifestation that we discussed. But from the outside, remember, if we are in any other frame, then of course we will just measure neural patterns, right? And neural representations and variables. Because it's relativity, as we said before. Okay. So now, yeah, 1 second. Yeah, if you know a bit about, you know, the philosophy theories, so it's not about the calculations anymore, right? It's about physics. So it's not reductive materialism. It's part of the physicalist view, and we need, in order to manifest consciousness, right? We need the principle of relativity and all that, relationalism. Right? So this is a bit different. So this was a summary. And now the question, how can we prove the relativistic theory of consciousness, or even better to say, how can we test it? For that, we need conditions. What are the conditions for consciousness? Well, now we know the conditions. The first condition, we need the causal closure. If you remember, we need to create a simulation. It should not be transient. It should be with somehow stable and continuous in some sense of a simulation. And then inside the simulation, we need to have variables of the internal cognitive frame of reference. And we need to have variables, those self-variables like valence, for example. And then we know that we will phenomenal properties will be manifest. So those are the three conditions that we need. Now the question is, yeah, okay, you know what? Before that, I have to, you know, people ask me all the time, so what do you think? GPT, does it have consciousness or not? The answer is, well, what do you think? Actually, according to the theory, to those conditions, those three conditions, do you have you know, a prediction here? Will LLMs have consciousness or not? You're right. No, they don't have, because even if they create a simulation, which is very doubtful, but let's say that they create a simulation of, let's say, all the relations between tokens, between words and sentences, still they don't have any variables about their own cognitive system, and not any valence or other self variables. So according to my theory, they don't have consciousness, although it can be very easy to do something like that, I guess, you know? The question is, do we want it? Now, what about other animals, like fish, for example? Do they have consciousness? Now, we can answer it maybe if we just know if they have those three conditions or not. Now, I don't know. I'm not from evolutionary development or something, but, you know, it can be interesting to check it out. My intuition is that a lot of animals will have it, because in order to survive better, it's, you know, it makes sense that they will have a simulation, and of course they need to simulate themselves and have valence. So I'm pretty sure that we need to go far away in the evolutionary scale in order to see animals without consciousness. But I don't know exactly where to put the line yet, but there should be a line. And here is something a bit weird. Babies, newborn baby. So this baby, for example, let's say that it's a newborn, although it looks too big. But do they have consciousness? Well, according to the theory, most probably not, because they still didn't learn all the relations to create a simulation at all. So then it's more like reflexes or something, and less. It's not consciousness. Only later on they will learn enough causations and relations from the inputs in order to create the simulation. When exactly? Again, I don't know. Excellent, interesting, research to check, right? When will they develop the simulation? Unless somehow we are born with some kind of functional simulation, but I doubt it. I don't know. We need to ask someone, from developmental or something. No? So those are just a couple of interesting questions. But now, first of all, how can we prove it? So first of all, in order to test my theory, so the prediction is, of course, that if one of those conditions is absent, we will not have consciousness. Will not be in a conscious state, right? So let's say that we are in a deep sleep without any dreams. I think that most likely, maybe we can say there is no consciousness there. So I guess, one of those, one or maybe all of those conditions will fail over there. Now the question is how to translate it into neuroscience, right? How can we know if our brain is, how can we know if our brain has simulation or not, or simulate itself or not, or have those variables or not? This is the question to you guys. But I do have two ideas. So let me show you. One of them is, of course, about dreamings. So, first idea, let's try to find a proxy of dynamics. What should be the dynamics of a simulation versus dynamics of no simulation? Now, it's very rudimentary idea, okay, I have to say. Maybe without a simulation, the activity of the brain will be driven by the inputs. Very highly driven by inputs. So we will have let's say the amplitude will be high because of the input, but then will go down after, the brain created all the calculations, and realized what it is and what should we do. And then again, another input, and after some, calculation and stuff, it will go, to be a lower activity. But then, in contrast, the simulation should be continuous. So if we have a simulation, the activity should be high all the time. And then the inputs should, of course, modify it, but it should be higher, and more stable, let's say, than without it. So then when we dream, for example, we should see this, high dynamics, than when we are not dreaming and in deep sleep, without consciousness. And of course, when we are awake, it should be like that as well. So this is one idea that I have. Now, the other idea is more cognitive about how it should function when we have consciousness. And then it's also, I think, it can tell us something about the engine of dreams. So let's take valence as an example for self-variable. Is it good or bad for us? Right? And this is our variable that will manifest as phenomenal consciousness. Now, as we said before, it interacts only with our first-person frame of reference, but it attached to all other inputs that we have, like the apple, right? Is it good or bad for me? I don't know, the red color, water, and so on. So the prediction is that our first-person first-person frame should influence back our sensory inputs according to to valence, because, as we know, of course, only when we are conscious. Why? Because let's say that, of course, we learned that, I don't know, red apples are very tasty, but green ones are not so tasty, right? So then when I see a red apple, I have high valence, I want to eat it, but it will influence also already the taste, how sweet it is. It will be even sweeter than what it should be, let's say, just because of valence, right? So it goes back because it's part of, it attached to the properties of the inputs, it can actually influence other properties of the inputs, okay? And because valence has relations only with our self first person frame, it means that in order for valence to change the properties, the other properties of the brain, we must see like an activity from valence area to area of this internal frame of reference, and then back to those sensory areas. This should be happening only when we are conscious, right? Only then we have all this complex system here. So let me show you. One second. Yeah, so let me show you what I mean. So the prediction might be that from the limbic system or the amygdala, for example, we should see activity flows, information flows to maybe the default mode network, because the default mode network, a lot of those areas are responsible for our self, our experience of self. So maybe this is where we have those variables in the simulation of the first person frame of reference. And then from there, we should see a flow of information back to the sensory, primary sensory cortex like V1 and V2, maybe A1, maybe even like, let's say if we have, I don't know, like a dream, but without any visual or auditory, but with like thoughts, then I would predict that this information should flow into maybe like the words, like the language areas, like maybe Wernicke, for example, Wernicke and so on. So now during dreams, it should be much more, how to say, prevalent, you know, because in dreams we don't have any constraints of the outside world. But during wakefulness, it will be different. So we have the same information flow to the default mode network, but then when when valence would, let's say, would like to change all those properties, all those sensory properties, there will be some kind of inhibition here, because we would like our simulation to be as suitable to the real world, right? We don't want it to be so like in dreams, right? So it should be much more constrained. So this can give us like an interesting prediction. While we're conscious and awake, we should see this kind of activity. While we are dreaming and awake, we should see it more, without those inhibitions. But when we are unconscious, then we should not see this, top-down modulation between the default mode network to the primary sensory areas. It also tells us something interesting about dreams. Maybe it's like the engine of the dream, because without valence at all, we will have no consciousness, right? So maybe as we have more and more valence, we should be like, how to say, more conscious, let's call it. So maybe if we have dreams, as the dream is more vivid, more emotional, more eventful, it means that we have more of this top-down modulation, right? Because valence is more active, so it active more the default mode network, and they active more all of our primary sensory areas. So this is maybe can be an interesting prediction to check with Sarah's data set, for example. So those are my ideas. Now, let me hear your ideas. What do you think about my ideas and questions and everything? And thank you very much. Wow.
So, anyone, including people at home.
Who wants to start? Also the Zoom people, of course. You can. I hope we can hear them as well.
I have to go. I think we'll find an intake.
Okay. So
The light was on.
thank you very much. Thank you. Yeah. So, any questions? I know it was very long and lots of stuff all at once. We started from the hard problem, how I try to solve it, and then in the end, you know, how maybe to test it. So, what do you think about some aspect of the theory? I don't know. Your choice. Martin, maybe you want
We were two. We start with the more juniors before.
to.
Like the old people.
Yeah.
But if there's no question or comment or
It sounds very logical, thank you, but
Thank you.
in a way, it's always very difficult to test hypotheses in practical and
Yeah.
science.
Yeah.
So of course we have some imaging techniques, but and a very interesting case with these girls who shows a picture when they have two girls who has the same.
Oh yeah, Tatiana, Krista and Tatiana. Yeah.
Maybe they can help us.
To ask their parents. Yeah.
From,
So they actually, so they are still alive. All those videos that I have, it's like at least 10 years ago. I think that at some point their parents stopped, you know, communicating anymore with the researchers. Yeah, but it can be very interesting to, yeah, to check them more deeply. That's true. Yeah.
Thank you very much. It was super inspiring. Also, really liked how you presented all of this art consciousness stuff.
Thank you very much.
Yeah, so I was wondering about your opinion on the things. So first of all, what do you think is on the base layer of everything? Do you think there's some kind of base layer? Is it information? Is it like fundamental particles, or is it all relativistic? Or
Yeah, good question.
or is it even the right question to ask? And secondly, I was wondering that you've probably heard about this recent paper where they kind of stimulated a new color experience by stimulating certain the retina in a pattern that is not naturally occurring. I don't know much details, but it kind of feels like a cool way, maybe, or something could be also
Interesting. No, I didn't know about it.
thing from last year. So
Huh.
science paper.
Interesting. Okay, I will check it out.
I didn't read it in detail, so I cannot tell you much
Yeah.
about it. But I find it pretty cool because it kind of shares the overlap between physical world and phenomenology. Kind of thing.
Yeah, I need to think about it. Maybe we can use something like that. Yeah, if you find the link, please send us over, and I will have a look at this. And for your first question. So this is a general question about what I think about reality, right? I mean, what is the basic? Is it information? What is it? So actually, I think it's about relativity, as you guessed. And this, so my idea, let's say, is that the principle of relativity is a very basic principle for the organization of reality as a whole. Consciousness is only the first step, let's say, or how I can apply this in order to, you know, to solve something, right? But my next papers will also go to different areas of physics. So yeah, I think that everything is relational and relativistic. So there is no absolute one basic elements, let's say, that the universe is composed of. Instead, it's all relational. And I have a very nice paper later on at some point to show how we can start. Like, what is the, you know, how, like what happened if you like, how the Big Bang could actually became, you know, with the principle of relativity. So yeah,
Yeah,
this is
looking forward to
exactly
it.
what I think. Yeah, but okay, for that you will need to wait until this paper. Now let's go back to consciousness. Yeah.
The other.
You said the newborn baby.
Can you just
You said the newborn baby might not have consciousness, actually. You said
Yeah.
it has no consciousness.
Yeah.
So, I mean, I'm not a physicist, like trying to understand from machine learning perspective. Like, think about a neural network that hasn't been trained yet.
Mhm.
It has its default weights. So even if it's newborn neural network,
Mhm.
comes with untrained
Yeah.
like weights that weighted to be optimized. That we
Yes.
call discrete optimization for survival of the environment.
Mhm.
But those weights are there. So, and it's filled with prior numbers that is broken.
Yeah.
Does that mean that this network is unconscious? If you just think as a baby, like,
Mhm.
and then you call it the training is like gaining consciousness. Is for them surviving. Then it means that like surviving needs consciousness. It means that it's for like environmental requirements, or I mean, I'm kind of thinking that it's supposed to be prior, like something must be prior that we call consciousness, then it is optimized between interoceptive beliefs in the belief network and then external outputs like action reaction loop. So yeah, maybe I'm getting lost. So yeah. So
I think
what
I
do you think
understood.
about prior?
I think I understood your question. First of all, let me start by, even if you think that consciousness is somehow about some kind of relationship between the inner and the outer, you know, states, right? It's not enough because it will not, you know, it's still part of the public third person point of view, right? So we need somehow to answer that, how to reach actual the phenomenal part of consciousness. That's why we did what we did here. And then let's check the conditions again. We need, first of all, a simulation. Now, the simulation means that we have a cognitive system that learned all the causal structures, and according to these structures, this causality, now it knows how to predict what will happen and what is going on now, right? It has some rules that it learned, and now it can do a simulation. Now, when we take a neural network, it's true, it has variables, some random variables even, to start with, right? It's still not a simulation. It didn't learn what are the structural, the causal structure, right, of the inputs in order to predict what will happen. So there is still no simulation. That's why no consciousness can be manifested yet. Okay? So that's why even if you take a new baby or a neural network, in the beginning they have no simulation, and that's why they have no consciousness. Only after they will learn it, and we create a simulation, and also they will create a simulation of themselves and of variants or other self-representations. Only then consciousness can be manifested in those internal frames. Okay, that's why I thought that babies don't have, or for that matter, neural networks. You know,
It's maybe a philosophical problem that like something also must create that neural network even before the training. So
yeah,
I mean, I have fundamental issue about like the creator of this network, maybe the consciousness itself. Some call it God,
okay.
or you can call it whatever. Like it's so is the then so can we go back even before the creation of the neural network, the architect, for instance?
Yeah.
Even before, like it's then that some kind of hierarchy do we have? Like
It's
can
an
we go
interesting
back?
question. It's like the question if are we part of a simulation? Like, is this all universe a simulation? I don't mean our inner simulation in the brain. Is our universe is a simulation? It's more or less the same question. Now, interestingly, we are stuck in an internal frame of reference. So we cannot measure. We have a causal closure, right, of the internal. So we cannot measure the outside, right? We cannot measure that there is a computer with electricity in the substrate of the computer, right? We measure only the causal relations between the variables, right? So we don't really know if we are part of a even bigger simulation or not. But in a sense, it doesn't really matter because it's still real, right? I mean, according to the principle of relativity, all those frames are real, and although all the physical properties are real, as measured and manifested in those frames, right? So it's interesting to know, but it's still real, at least, right? So we don't really know how to, we cannot really answer that because of actually of relativity and the frames of reference.
Actually, I think in one of those books, Thomas Metzinger makes this comparison between opaque and transparent kinds of simulations.
Yeah.
That if you interpret what's going on in the brain during wakefulness also as a kind of simulation, then you can, on theoretical grounds, come to this conclusion or so, but it will always be opaque. We do not feel it as a simulation. And the same is in normal dreaming, where we also sort of feel it as our normal world, even though sort of out of the wakefulness perspective, we can see, okay, it was just simulated and not real, and even though we didn't notice. And lucid dreaming being the exception, where we have sort of a transparent view of the simulation, that we are in the simulation, but sort of immediately sort of not only theoretically come to the conclusion it's a simulation, but can actually feel it to be a simulation.
Exactly.
That's
So
one
Metzinger,
strategy to look into this and sort of bridge these different levels of descriptions.
yeah. So Metzinger, it's true when he speaks of the transparent, he calls it transparent. This is exactly the immediate, that what I described before as immediate. This is his way of describing the same thing. Now, yeah, you're right. In dreams, we are stuck in the frame of reference, of course, it's the same simulation as we are in in wakefulness. But then it's weirder, of course, because of this engine of valence, and we don't have all the constraints. And then it's true that we're missing some cognitive capabilities, right? To say, hey, wait, something here is off. So I do sometimes lucid dreams. I use the method of the watch, you know this method? When you look twice at your watch, and first time you see, what is the hour, what is the time, and then you look again and you see that the time is changed. And then so you do it a lot of times when you're awake, you see it's the same time every time, but then when you're dreaming, you will see it's different and you're in a dream. It actually works. Like for me, it worked. Now I don't even need that. I just know that I'm in a dream, and I like jump. And if I float, I know that it's a dream. So, but how it works? It works because we have some memory capabilities, and we can compare with memory that something is off now in the simulation, right? So that's just because we have this comparison. So if we try to think about it here now in reality, right? In this third person frame of reference or something, we need a comparison, right? We need somehow to compare to some other information. But the only information that we have is either while we awake, dreaming, or maybe take psychedelics, right? Meditation, stuff like that. So it's hard to know from those comparisons what else do we have, right?
I mean, with lucid dreaming, you break these barriers of description, right? Because there you are in one sort of causally, oh, you feel it as causally closed world. And in non-lucid dreaming, it's like is all closed. But as soon as you get lucid, then you sort of get this.
Like higher.
And realize it to be a simulation, and you can of course even interact with the real world. So it's sort of trans reality or trans consciousness.
Trans frames, you know. Yeah, exactly. Like.
And I'm not sure if that helps in any way, but for me that if it's a problem that you have these causally closed realms, then lucid dreaming might be one kind of solution, like how to overcome this. I don't have any suggestion for experimental setup or study or so, but maybe that's.
But it is, I need to think about it. It is very nice idea how to do this, like this. To use the dream and lucid dream in order to somehow merge a bit the different frames of reference at some point.
I just yesterday, somehow, I'm not sure if that happens with anyone else, at least of the seniors. In recent months, I get many more sort of like people mailing me about their dream experiences, and I think it's about ChatGPT, that they sort of ask ChatGPT, I have this weird sort of experience, sort of whom to ask, and then ChatGPT refers to me. And like some of them explicitly told me, sort of, I asked ChatGPT and recommended like asking me. It was sort of like, since I started with dream research, that every once in a while happened. The craziest people come and ask about their dreams, but it happened every 6 months or something. And now it's really super regular. Every week I get another. Yesterday I got an email from a very interesting person who says she's almost always lucid. Can completely control her dream, and including the dream environment. And one weird thing was, besides this, was that she dreams in black and white, which people in the 1950s had the feeling they would do, which was probably because of black and white TV back then and misinterpretation or something. But this apparently is not the case in her case. But one interesting piece was also that she said she often has a lot of sort of very vivid dreams and so on, where she's still very aware of the environment. And I'm not sure if that might also be just some dissociated state during being awake, or something that doesn't just fit our sort of like clusters of states.
What does
it might be another possibility to see sort of if it's sort of possible to break out of this partial.
Also, if it's true, if she can do lucid dream, and usually it's black and white. And she say that she can actually manipulate the environment.
But she said she cannot manipulate the
colors.
So apparently that is not possible. But
I see. For her. Well, maybe she need to practice. I mean, in the beginning, of course, when I lucid dreamed, I couldn't manipulate the environment. But then, I heard some lectures about the dream meditation that Buddhists do. And then they have some set of exercises, like to, for example, to multiply yourself, or to be the other gender, or to be taller and stuff like that. And then I started to do it, and I succeed, right? So it's something that you can actually. So maybe it could be interesting, because if she can do it, then we can show, for example, that when she actively wanted to be with colors, we can see like a top-down modulation to V5, right? The colors, right? Or something like that, right? It will be interesting just to show something like that. It reminds me, I mean, a lot of things that you do, right? You use those lucid dreaming in order to show something about the mechanisms of the brain, right? So it can be interesting. Okay, but let's see more questions. See that you have something?
Just a little thought on that. I think this with the lucid dreaming is probably a very good idea, because it's still frontier enough also how it really works in the brain and stuff. I was a little bit worried with the other hypotheses that maybe too much is already known on this broad level, that it's maybe a bit maybe too colored as hypotheses already, but with lucid dreaming, I think it's
Yeah,
Would be
I think
interesting.
there are a couple of published studies that basically show already, at least your first hypothesis, that sort of like in a conscious state, you have sort of ongoing oscillations, and you're in the non-conscious, it somehow tapers off quickly. And there's on the one hand, of course, and that is very similar to Sarah's study or sort of data set from Francesca Ciclari,
Yeah.
that like where they have the repeated awakenings, and then they have those cases where people say, yeah, there was nothing. Or these three cases. So they had people reporting about their dreams and remembering, therefore, then people saying, I'm sure that I dreamt something, but I just forgot. I have no clue what it was. And then the third case where people were saying, I was sure there was absolutely nothing. And the first two cases on the neural level were very similar, but different from the third case. So there might be indeed periods of complete unconsciousness during the night. And that data exists, and whatever very specific hypothesis you would have, I mean, you can of course already see in the paper, of course, it's related to sort of like slow wave activity, and the more slow wave activity you have, the less likely you report about having a dream, and the more of the higher frequencies, the more likely you are to report dream remembering or not. But if you have very specific hypothesis, then of course that data is there, and very similar to Sarah's data, and could be used for that. And then there's of course also the studies from Marcello Massimini about TMS and traveling waves, that also shows that depending sort of in slow wave sleep versus other sleep stages of wakefulness, that if you in a sort of physiological state that you assume to be related to less consciousness, the traveling waves very quickly sort of, which direction was it?
Right.
They went for longer
Deep
or for
sleep.
shorter? I'm not even sure anymore.
In deep sleep, the TMS faded quickly, and then while in wakefulness, I think it was, it continued much more time, right? Something like that. It's similar. No, it's not exactly the same. But yeah,
but of course that would not be a very sort of powerful hypothesis if it has already been shown before you come up with a hypothesis.
That's true. Another slight different, but still similar, is to say that the background activity should be more or less stable, because the background activity is like the background activity to create the simulation, so that the input will cause some differences, but we need to see that the background activity is all the same. And without consciousness, this background activity either will be absent or just will be very influenced by the inputs. So maybe we can make a little bit different prediction here that won't be so similar. I don't know. But maybe something of that, of the background activity in comparison, or something like that. I don't know. Or just to go to a different approach, with the valence and the top-down modulation, or something like that.
I didn't fully understand this one. I mean, your example was always the apple, and then sort of how valence sort of modifies the apple. But if there's no consciousness, there's also no conscious experience of the apple. And so far, there's nothing to top-down modulate.
Yeah. Okay. But then if so, but there is still a spectrum here. If we have a dream that is very vivid, very eventful, then most likely it's because we have more activity of this valence and top-down modulation, and that's why it will be like more vivid, more conscious, if you like, and then also more active and eventful, just because the valence will influence more the sensory inputs that we see. So the sensory input will change more. So the scenery of the dream will change more in accordance with the emotions, I guess. So there is a gradient here. We can say that maybe a very simple dreams will have much less top-down modulation, but very complex and vivid one will have more. You know? So maybe this is something that we can do. Of course, at some point, the best thing will be to go even further to like a content, different content. You know, like you have the stimulus, but it's unconscious versus stimulus that it is conscious, and then to show there maybe that there is a top-down modulation.
Yeah, this is like Tristan's data. So in Cambridge, he's been playing sounds while they were falling asleep, and then they can report if they're aware of it or not aware of it. So you have kind of the same stimulus, but different states of consciousness.
Right. And then according to the prediction, if they are aware of it, we will see top-down modulation. When they are not aware of it, they will not see it. And also, of course, the activity will decrease very quickly. So yeah, this is another thing that we can check. Right? So not only about states of consciousness, but also content.
In dreaming, there are also different kinds of integration of external stimuli. It can be that there's just nothing sort of arriving, either sort of on the physiological level or on the phenomenal level. It can be that sort of external stimuli are sort of entering the dream, but coming out of nowhere, or they are completely incorporated into the dream. And Leila Salterson did a PhD on these things until last year. She had an idea about sort of on the neural level how these things sort of differ depending on how deeply they're incorporated. Not clear if that's relevant in any way.
It's very relevant. Yeah, it's very relevant because it's the same thing. If the stimulus didn't penetrate, then we are not aware of that. If it is, then now it's a conscious state. So according to the prediction, when it did penetrate, we should see some, again, I don't know exactly how the details are to do it, but we should see some top-down modulation, you know, from the default network to, you know, about it. And if it didn't penetrate, then we should not see this kind of modulation. So it should work, I guess, also with that. But so do you have such data? Do you have like?
No, Leila back then, I can send you her review. She did a very in-depth review over probably every study that has ever been done on dream integration or sort of stimulation. And then on a more theoretical ground, sort of came up with this model. But this paper, either way, might be very interesting.
Yeah, it is. It is. Yeah, I would gladly see the link. Just one question for Sarah. If I remember correctly, Sarah, you don't have such data, right? You didn't try to do also like integration of like outside.
Not in that detail, right?
No, I mean that wasn't really the main focus. I guess we could ask Julia. Is that one thing that Julia tried to do?
Did Julia did something like that?
Yeah, Giulio Bernardi.
Not
on. Yeah, it might be. I'm not sure. I mean, and Sarah, in your data set, I mean, there is at least indirect evidence if something arrived or not, because there were stimulations during sleep, and then people were asked about it. But it's
but obviously we really try to not have that at the level that it kind of disturbs them, and so I think it's kind of different, like compared to like I don't know an alarm or so being then incorporated, right? That gets very loud, and I don't know. I think we only had like one or two things where you could potentially say they're kind of direct incorporations like that of like the words, but yeah, I don't think we have enough data.
Yeah, but even if we don't have, it's okay. I mean, still we can start from different, you know, to check different, you know, about conscious states, and later on think about the stimulus, like, you know, the content. You know, we can still start from other from the other two ideas, you know, that just check the difference between states, I guess. And also because Sarah, I remember that you have the, of course, regular dreams, let's call it the visual one, but you have a couple of those only auditory and like dreams of only thinking, if I remember correctly. Like you have a couple of types, right?
Yeah, so we asked them basically what kind of modalities they have, and there were some that are not visual, or that are just kind of songs or things like that. Yeah, again, not a whole lot. Obviously, most of them also have a visual component, but there were a few at least in there.
Yeah, because then we can check, does, the top-down modulation should go not to V1, but to A1, for example, right? Or with the thoughts, actually, if it's only thought and nothing else, this would be interesting to see whether, if this like top-down modulation, where does it go exactly? It should go to some kind of, the creation of a thought, I guess, area, linguistic areas or something, I don't know. So yeah, it can be interesting to check all those
I
different.
think generally the difficulty will be, of course, to really map these hypotheses specifically to your theory, right? That to say, like, how does your theory differ from other theories? Because that sort of top down and bottom up like makes some differences in consciousness, and so this is probably something nobody would be surprised by. So in how sort of what are the specific hypotheses that you can build with your theory that all the others don't, or at least some of the others don't?
Yeah, what I thought is interesting here is that, of course, valence, for example, should influence the output, right? So, I don't know, like a premotor area or something like that. But here it's something a bit less trivial than that. It should influence also the inputs themselves, like the primary sensory areas. So I thought maybe it can be more interesting because of that. And to try to check, Tristan has lots of tools from information theory. All the different entropies in order to check the uh, flow of information. So then, if we can show this flow of information from a limbic to, let's say, default mode, like medial prefrontal or something, and then to V1, and this can be maybe interesting.
The question would still be sort of in how far does that really distinguish your theory from others, since that I think there are plenty of studies in social psychology that show that if people, I don't know, have the feeling or are being told that an apple is sweeter than the other, then they experience them as red or something like that. There's probably plenty of behavioral research on something like that. And if you would ask a neuroscientist, sort of how is that represented in the brain, they would probably come up with a similar sort of explanation. But in how far does that then really sort of distinguish your theory from other theories of consciousness? I think that is, I mean, if you do the experiment and it turns out to be like a correct hypothesis, so in how far would you convince other people in the consciousness field that your theory is correct or better than others?
Yeah, that's a good question. I mean, I think, of course, we need to compare it to non-conscious states to show that over there it will not happen.
No.
And then maybe it is already a good start.
Yeah, but again, then probably all the other sort of people in consciousness field will say, well, obviously our theory would say the same, that if it's not conscious, there's less happening in the brain and less top down and so on.
Yeah, though I mean, IIT, for example, it's not about cognitive abilities at all, right? I mean, it's targeted information theory, about this phi higher than zero. So for them, it's like it's not even relevant for consciousness, right? So, it depends. It depends, I guess, on the theory. But yeah, again, I think that the better thing to do here is to compare the stimulus. If it's entered, did it enter consciousness or not? And if only when it entered consciousness to show this modulation and not if
And I think that the most promising is probably to find a hypothesis that is highly counterintuitive. Where most people would say, well, that sounds crazy, but if your theory predicts it, and then it turns out to be the case, then I mean, it's similar to Einstein, right? They're also like that. That's what was cool about it. That
Right.
came up with the craziest ideas that they turned out to be true.
Yeah,
And,
yeah.
probably something like that would be needed if you sort of test only the stuff that everyone else would say, well, obviously, yes, and we agree. And
Yeah, maybe something like this of the baby, newborn baby. This is a bit unintuitive, right? So-
yeah, that I mean, what is ground truth there? So I would say
Yeah.
that obviously the baby is conscious because like you can sort of anesthetize them and then they are different, and in one case they're conscious and the other they're not. But and therefore sort of if your hypothesis says they might be unconscious, it's obviously sort of a different sort of meaning or concept of consciousness than sort of the everyday language there. And if you have that, then what would be the ground truth that you could compare to?
Right. So then what I would say, I would suggest, first of all, we need to do this, let's say this, well, we don't see it anymore, but the usual, my idea of the top-down emulation, for example, or something with the background, how it changes, right? So we do it in the dreams, the wakefulness, and deep sleep. We show that over there it happens, even if it's not that surprising. And then we go to the baby, newborn babies, and show that over there it will not happen, right? It's like a more interesting prediction. You see, now new babies seems like don't have consciousness because
I would, I mean, I would then rather, if you show that the baby that is not anesthetized and that reacts to stimuli and so on, and your theory then says, oh, it's non-conscious, then I would say, okay, your measurement from your first experiment is not an appropriate sort of conceptualization of consciousness if it so clearly fails in one of the paradigmatic cases of consciousness. Same as, I mean, say your theory then, or the same results, you would then say that someone who just awakens from anesthesia and then says, oh, and like after he woke up, he's unconscious, but before he was conscious or so, then obviously that is sort of a demonstration that the original sort of conceptualization or sort of how to define your measures was misguided.
Yeah,
or sort of denotes something that is not commonly like considered consciousness.
Yeah.
But nevertheless, I think that it's if you come up with a surprising hypothesis, that will certainly, I mean, a single experiment will never completely like prove or disprove a theory, but it will certainly raise a lot of interest then. I think that is the best that you can probably do. Right. Most models or all models are wrong, but some are interesting.
Some less than others. Yeah. Yeah, I mean,
You did.
I also have to
Have to go, but the room is empty for the next hour.
Yeah, I also have in 15 minutes I have an important meeting.
and just one thing to say that let's take IIT for example. They don't have still a very good proof. The only thing that they did is this TMS, right? The TMS, which is more about integration, let's say.
Yeah, I think that is a problem of the entire field, of course. That also with these adversarial collaborations. I mean, what they in the end came up with are like very trivial experiments and observations that are just not suited to completely sort of prove or disprove theories. And my general impression is like that these sort of grand theories of consciousness aren't really helpful. Unless they make very interesting predictions, but so for me is I mean, like I did my master's in my first master in B and actually on the philosophy of LLMs 20 years ago. Wasn't known yet. But
They talked about this back then.
sorry,
They talked about this back then.
I mean since decades. I mean the Chinese room experiment from Seoul is about LLMs, and that was my master.
And about AIs.
Exactly.
Yeah.
And I sort of the first couple of years after my master, I went to every ASC conference and so on. But at some point, really, lost a bit interest because it's like it didn't lead anywhere at the feeling, right? Sort of there's since decades there's this fight about the theories, and not a lot of progress has been made, and not a lot of very interesting predictions have been made, and we don't. For some reason, I don't think consciousness is so special as everyone in the consciousness field thinks. I mean, nobody would sort of aim for sort of having the one answer to memory, because of course it's complex. It's just like consciousness, you can do a million things and learn a million things, but you do not need this one answer to one single question there. And I think that is what a bit the consciousness field suffers from, that it's all about finding this one theory and this one answer to this one question, and it's so far it hasn't sort of led to a lot of progress, I have a feeling. But if sort of the theory predicts something really surprising, and therefore sort of pushes progress and activity sort of in other fields, that is, I think, the best one can hope for. But it would be very, very valuable, even if it might not be the answer to the question of consciousness.
Yeah, of course, that in consciousness it's a bit different than memory, because we have this explanatory gap, this very interesting mystery.
I don't see that.
Yeah. Even though my beautiful introduction,
I started studying philosophy the year Sharma's book came out, and I was convinced from day one. I think that the best sort of description about sort of first and third person perspectives was making a metaphysical mystery out of a grammatical triviality. Sort of if there's something intrinsically important about first and third person perspective, what about the second person perspective, which was meant as a joke 20 years ago when people came up with this, but since 10 years there's a second person neuroscience. But it's completely unrelated.
Yeah.
But I think it's nevertheless, it can be very valuable. But you need to, in my view, you really need to find these interesting hypotheses that really are counterintuitive, and therefore can really make a difference.
Okay, yeah. Well, I need to think about something more counterintuitive. Still, I think it's okay to start with something, right? I mean,
absolutely.
If we can show, for example, that again the background activity is stable with consciousness, but not stable without consciousness, and show it also in dreams versus awake, but also stimulus that is conscious or not conscious, already something.
For dreaming in particular, also wakefulness, but dreaming in particular, of course, what we lack a bit are theories. I mean, there's a bit of the opposite in consciousness research per se. We have plenty of theories, but they lead nowhere. In dreaming, we have plenty of empirical data, but no really sort of overarching coherent theory about like how dreams are built and what they are for and so on. And I think that might really be the most fruitful way to somehow sort of indeed combine the sort of wealth of empirical data and just descriptive data that we have in the dream field with a more sort of theoretical point of view from the consciousness field. And that is in a sense trivial, because dreaming is of course a state of consciousness. But that was what puzzled me since decades, that it's somehow like such separate fields. That I mean, there are people interested in, like people in consciousness field interested in dreaming and vice versa and so on. But even though dreaming is such a sort of striking example of a like altered state of consciousness, it's highly underutilized in the consciousness field, and that might therefore really be the value of trying to bring
exactly. I feel the same. It should be so trivial to check the theories of consciousness with dreams.
Not trivial, but valuable.
Trivial to try. I mean, right. And not a lot of people are doing this. And for me, I think that this valence, this is exactly where we need to check, because it's like the engine, right? When it's
and that might even sort of like make a bridge to clinical applications, right? Because that's of course where dreaming becomes sort of clinically relevant when it comes to sort of increased valence in dreams and nightmares and that might be really interesting.
And also if for some reason the inhibition decreases while we're awake, then of course we have hallucination. stuff like that. So yeah, it can be interesting to do that.
Yeah, I've been going to Gordon for many years, and one of the things that I always feel is missing is like a session on the functions of sleep.
Yeah.
So we talk about,
I
specific.
think 2 years ago,
different
even the
systems.
entire conference was called functions of sleep, right? Or
Yeah, but
sleep-
it was very, so this is like cardiovascular and there's immune and there's nothing like this big picture of why do we think we need this function? So the same about dreams, like this kind of meta.
Yeah, or the function of
Analysis.
dreams, or
The-
the mechanism
yeah.
to receive any, right? Like, exactly. Yeah, so maybe I
Actually,
can
this
contribute.
can be an interesting kind of edge case
Yeah.
of a simulation,
Which one?
nightmares.
Nightmares.
Did Sarah have like some sort of?
Sarah, do you have a nightmare data set?
I mean, there are some dreams they rated as like very negative, but we don't have nightmares with the definition of that they woke themselves up. I don't think. I mean, this is very rare to get in the lab.
Even if you just use this parametric variable that you I mean it's like arousal and valence, right? So,
Yes.
yeah. So far you have that for 1,000 awakenings, so that's plenty of data.
Now we have some resting state fMRI in people who report frequent nightmares, like more than once a week. So we have like hundreds of those. So maybe we can start by just showing like cross section, or maybe
we don't have hundreds of the very intense, but we also have 900. So in our Healthy Brain study, we have 900 participants, which had 3 MRI sessions plus 20 nights of sleep EEG each. And there we also asked about nightmare trait, so nightmare frequency as a trait.
So did you find something in the brain?
We just finished data acquisition too.
Wow.
Pressure trove and so far, not really.
Wow. Well, if you want to merge the data sets, I'll be happy to. I was thinking of looking into some exactly kind of limbic emotional regulation pathways, and maybe even amygdala volume, because that tends to change with anxiety and things like that.
I mean, in particular, if there were some ideas about how the MRI, resting state MRI stuff might relate to nighttime sleep, then we would have the data in all those participants. It's sort of 2-channel EEG, so it's not very complex and nothing on a source level, but if it's just about some whatever oscillations or general activity or background activity or something, that might be possible.
Right. But okay, with Sarah, we do have the very negative dreams even, and then become more interesting. Maybe we can show like again like more valence go, like flow of information go to the sensor areas much more, or something like that. This scale of valence activity or top-down activity or something like that. Yeah, it can be interesting. That's true. Okay, great. So yeah.
For Sarah's data set, obviously you have to discuss with Sarah about the details.
Sure.
With a healthy brain, we can further like discuss it. It's really I mean, it was sort of whole campus was involved here, and it was meant as a data resource. It was not that anyone said, okay, I want to test this hypothesis, therefore I collect data. It was really meant as a data resource. And yeah.
So they have resting state, and
we have we followed them for 1 year, and every 4 months they came in, and then we sort of treated them with everything we have here at campus, from MRI and genetics and gut microbiome and cognitive testing and whatnot.
And these are people that
the entire week before their visit here. So during that visit, they always had an MRI scan, resting state and structural. And then the entire week before, they had every night they had a sleep EEG, and during the day even a couple of sort of prompts on their smartphone to ask about stress and mood and these things.
Those are people that have lots of nightmares, right?
No, it's just general sample from the population, but we do have the trait nightmare frequency data. So there will be some who never have nightmares, and others have it very often, and everything in between. And same for general dream frequency and for lucid dreaming frequency.
So then, yeah, so you do have an EEG maybe of people that had nightmares maybe in this data.
Yeah, potentially, yes. I mean, we didn't ask in the morning if they had a nightmare in this specific night, so it's really all trait data. But I guess there are ideas how to sort of bridge those, again, levels of descriptions, levels of.
So we have, it's once a year they come in for a scan, but they do a lot of cognitive, they do a lot of questionnaires, they do some heart rate kind of biofeedback modulation, and social stuff as well. So that's kind of what we have. And they do resting state, but they also do breath hold, which kind of gives you a very strong hold response across the brain. So they're also very interested in your HRF and kind of your blood flow during the scan and how that changes with age. And yeah, and so far they have like hundreds. So what I like about, so what we do with sleep right now, it's not EEG yet, it's just questionnaires, but it's the PISCI, so you can really target the kind of nightmare frequency question. And when we do that, so we kind of go into like 300 people that we can compare.
Good. Here is the novel color, yeah, that he was talking about.
I also sent you the single case study. Yeah, so we can think about
Absolutely.
asking maybe similar questions to data sets, and it'll be a really big cool. That'd be great.
Excellent. All right.
Okay, I really have to move on now to the.
Thank you.
Thank you very much
for coming and having us here.
Yeah, thank you very much for dropping by. And then you were already in Amsterdam, or you are now?
Yeah, so Os's group invited me to give a talk, and then we
Perfect.
Yeah, that's why.